Okay, so let's talk about this whole finding out how many numbers that exist. Okay, so one thing to kind of look at is how many digits are there in each number. So for instance here, how many area codes were possible before? Actually, let's skip that one. So let's look at the 7-digit numbers. So the 7-digit numbers in a given area code have the form A, B, C, X, 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 where X, B, and C can be any digit 0 through 9, and A is restricted to 2 to 9. Okay, so, and then we have two other restrictions which we'll get to together first in a minute. So before we even talk about restrictions, right, what we really want to look at is what can we possibly create out of this? How many total possibilities are there available with this under these parameters? And then we'll take out anything that's restricted. So, a 7-digit number. So the fact that it's a 7-digit number tells me that I should have 7 digits laid out. So they lay it out for me, but even if they don't lay it out for you, you can always just lay it out yourself. So 1, 2, 3, 4, 5, 6, 7. Okay? So I've got a 7-digit number, okay, and we know that X, B, and C. So all of these, right, are going to be any digit from 0 to 9. Okay, so that means for all of these down here, they're going to be any digit from 0 to 9. 0 to 9, 0 to 9, 0 to 9. Well, you have to think how many total outcomes are there for each one of those. All right, so 0 to 9 gives me 10 possible outcomes. If you count it out, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because we're including the 0. Right? 1 through 9 and then 0. The fastest way is just subtract and add 1. 9 minus 0 is 9, and then add 1 more makes 10. Okay, so there's 10 possible outcomes here. 10 here, 10 here, 10 here, 10 here, 10 here. Okay, 10 outcomes for each one of those things. And then it says A, which was the first letter, was restricted between 2 and 9. Okay, so 2 to 9. So again, fastest way, so this is 2 to 9. You can list them all out and count. 1, 2, 3, 4, 5, 6, 7, 8. Right, or just subtract. 9 minus 2 makes 7. Add 1 to that makes 8. That's how I do it. Subtract and then add 1. Okay, so to figure out the total number of possible, right, that would be that right there. You just got to multiply all of that out. So multiply all those numbers together, okay, and you just end up with 8 with 1, 2, 3, 4, 5, 6. 8 billion. Okay, so 8 million different possible combinations, not including restrictions. So then it says B and C cannot both equal 1. Okay, since these values are designated for other purposes such as 911 and 411. Okay, so let's talk about that restriction. So when we try to figure out restrictions, we don't try to go back to this and change this. We don't want to do that. We want to figure out how many of these numbers would have had both B and C equal to 1. So since they can't equal 1, we're going to go ahead and make them equal to 1, and then we're going to try that. So B and C cannot both equal 1. So what we're going to do, right, so B and C are the second and third numbers, right? So I still have this 7-digit number for my restriction. So here's my first restriction. Okay, we know that the first number is still 2 to 9, so I still have a 7-digit number. 1, 2, 3, 4, 5, 6, 7. Right, still have 7 digits. Okay, the first number is still 2 to 9. Okay, so we're going to make that 8 different outcomes. Okay, well, here, this and this one, right, we're going to make them both 1. Because we want to know how many numbers could I create where both B and C are 1. So let's just make them both 1s. Well, if this is a 1, that means it has one option. If I make this one a 1, it has one option. All the rest of them still have the option to be 0 to 9. Which means each of those last 4 can be 10 possible outcomes. Times, 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 times. Oops, sorry, too many times. Alright, so then I just multiply after that. So when it says we can't be both 1, make them both 1. Because this is going to tell me how many numbers to take out of that total. Because this total right now is including all these numbers where B and C are both 1. So we have to remove those from this total. So once I multiply this out, I get 8 with 1, 2, 3, 4 zeros, right? So 80,000. So I'm going to take these 80,000 numbers that I could write that have 1 in both the second and third position, and I'm going to take those out of my original 80 million. So minus 80,000. Okay, and then we've got our second restriction. So let's go restriction 2 over here. Restrict 2. Okay, restriction number 2. This one says all the numbers from 5550100 through 5550199 are reserved for fictional use such as television shows or movies, right? If you ever see a TV show, they always start with, what's your phone number? 5550152, right? So it's all these numbers in here. So a couple ways you can do it. You can kind of just look at the fact that we go from 100 to 199, right? So 0 to 99, which would make 100 different numbers. Or we can go back to this same exact concept. So let's just do it this way because I think this will help to see how all this stuff progresses. So I still have a 7-digit number. 1, 2, 3, 4, 5, 6, 7. We're going to see how many numbers can I make from 5550100 to 5550099. Well, the first number has one option. It's just 5. Second number has one option. It's just 5. Third number has one option. It's just 5. Fourth number has one option. It's just 0. Fifth number has one option. It's just 1. Sixth number goes from 0 to 9. Seventh number goes from 0 to 9. So writing all that down, I've got one option, one option, one option, one option, one option. 0 to 9 is 10 options. 0 to 9 is 10 options. Multiply all that out, and I get 100. Okay? So it's the same sort of concept of just looking at that and saying, well, I can create 100 different numbers from 0, 100 up to 0, 199, right? 0, 0. So you can do 555, 0, 1, 0, 0. 555, 0, 1, 0, 1. 555, 0, 1, 0, 2. 555, 0, 1, 0, 3, right? You can keep doing that. So you got all the way up to 0, 1, 9, 9. And same thing that we did with the 0 to 9, 99 minus 0, 0, right? And then plus 1 gives me 100. But this way works as well, right? I created a whole number. I restricted each one of them because all of the first numbers were 5, so I just restricted them to all be 5s. That means one option for each one, right? Total number of outcomes, just one if I say this number will be this. All right, so then I would take that 100 out, okay, and then just use my handy dandy little calculator. Take 8 million minus the 80,000 minus the 100. Okay? And you should get 7,919,900. So that's how many phone numbers I could create, right, using this method. So the first one is restricted down to 2 to 9. Okay? We don't include anything that has 1, 1. Right, because we took all of those out. We figured out how many total numbers we could create that had a 1 and a 1, and we took those numbers out. And then we took out all the numbers that fit between 5550100 and 5550199. Right, that was restriction 2. We subtracted those out of our total, and that leaves me with 7,919,900 numbers that I could possibly create under this particular system. Okay, so that's how those restrictions work. That's how the fundamental counting principle works. Right, and that was pretty much all the rest of that stuff. So same sort of thing. I'll do one more that has letters in it just so you can kind of see. So how could you determine, let's just calculate how many plate numbers New Jersey was able to assign. So let's just look at that. Okay, so if I look up here, New Jersey, originally, recent, blah, 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 3 numerical digits followed by 3, but because we're running out, usually change system. Okay, so the original number for New Jersey, right? So we had 3 letters, followed by 2 numerical digits, and 1 letter, right? So 3 letters, okay, and I'm going to do this right here. So 3 letters, 1, 2, 3. I'm just going to write A so I know they're letters. 2 numerical digits, 2 numbers, and then 1 letter. Okay? So here, when I'm looking at this, they never said which letters were allowed to be used. They never said which numerical digits were allowed to be used. So I'm going to assume, and this one asked, what assumptions did you make? I'm going to assume that we can use all the letters and all numbers, because they didn't say anything else. So I'm going to assume that I'm going to use all my letters and all my numbers. So, in case you didn't know, there are 26 letters in the alphabet. You do need to know that, though. There are 26 letters in the alphabet. So for each one, this could be any number from A to Z, A to Z, A to Z, right? 0 to 9, 0 to 9, and then A to Z. Alright, those are all of those possible combinations. So like my very first one in this sequence would be AAA00A. And then AAA00B, AAA00C, right? So on and so forth all the way down. So fundamental counting principle says find the number of outcomes for each one, and then multiply it all out. So A to Z is 26, A to Z is 26, A to Z is 26, 0 to 9 is 10, 0 to 9 is 10, A to Z is 26. Multiply all that out, and that gives you your final answer. So 26 times 26 times 26 times 10 times 10 times 26. Okay, so multiplying all that out would give me 6, 9, 7. Hold on, let me write it first. Alright, 45,697,600 different license plates that we could use for New Jersey under the old system. Okay, that was under the old system. So that's what that stuff looks like, and then if they restricted it, we can go from there. So if they said, let's just make one up just to kind of give you a little extra. So let's just say that they claim that all 3 first letters can't be the same. Okay, so let's say that that's their rule. That's one of their rules. So all 3 first letters aren't allowed to be the same. Okay, so I wouldn't go and try to take them out of this. This is my total. I want to figure out how many of these I can create. So don't try to take it out of here. Okay, go back and say how many numbers could I create, or how many license plates could I create where my first 3 letters are the same. Right? Calculate how many do exist under those rules, and then take them out. So let's say I wanted all 3 of them. So you have to be very careful here, because we can't just say take 1 off of all of those, or 2 off, or 3 off, because I can do, like, the first 2 can be the same, okay, and so on and so forth. So what I'm looking at is the 3 of them as a group. So I've got A, and A, B, and B, C, and C, D, and D, E, and E. So how many, right? So my first thing was, of those first 3 letters, how many combinations could I create where all 3 of those were exactly the same? Okay, well, A, B, C, D, E. So for those first 3 letters, I'm going to group them together. So the first 3 letters, right, cannot be all A's through all Z's for those first 3 letters. Right? 2 numbers and then a letter. So for the first 3, I'm going to group all those together and say A to Z. Well, that's 26 letters. All A's, all B's, all C's, all D's, all E's, all the way up through Z, right? So that would be 26 combinations of all the same letter. And then the number still says 0 to 9, 0 to 9, and the last one doesn't matter, so A to Z for that one. Alright, so I just grouped them. A to Z makes 26 combinations, and then 10 combinations, and then 10 combinations, and then, oops, that's A to Z, and then 26 combinations. So that would give me a total of 67,600. So that's 67,600 license plates that I could create where all 3 of them are exactly the same first 3 letters. So then I would have to take all of those combinations out of my original number. So then I would go and I would take 67,600. Oh, it works out to be real pretty numbers. I like that. 45,630,000. Okay? If you take out license that start with the same 3. Alright, so if you take out all those repeats, right, that's how many you would end up with. So if I take out the 67,000 license plates I would create, that would start with A, B, C, D, E, F, all the way up to Z, right, then that would look like that. So you can group them together, right, to figure out when they say stuff like the first three letters can't be the same or the second two letters can't be the same, something like that, you can always group them together and figure out how many combinations of that will happen, and then take that out. Okay, so that's figuring out, calculating how many numbers you can create.